Welcome, great Masters Vessel students. You are welcome to another session of chemistry class. Today's lesson is separation technique. Remember, I'm your chemistry teacher, Mr. Odemenam Chidube. Under this topic, the learning objective, what the student is supposed to know after this lesson is 1. The various techniques employed in separation of mixture. The various techniques employed in separation of mixture. The second one is how separation technique are applied in industry. How separation technique are applied in industries. Then the third learning objective is how to test for purity of substances. This lesson, we'll call it lesson 1, but this learning objective will serve for 2 lessons. Therefore, as we go on, we'll be dealing with the learning objectives. What we need to know first are the types of separation technique. Types of separation technique. Maybe there is need for us to know, when we talk about separation technique, we are talking about substances that are not pure, and we need to remove either the impurity or to remove the pure substance. Therefore, when we make substances and there is impurity in the substance, we need to remove the impurity so that we can get the pure substance. There are some basic properties that help us to make effect separation. Some of the basic properties are 1. Size of the substances that make up the mixture. For instance, if you have rice and you have some small stone inside it, you discover that you can either remove the stone by picking, or when you are washing it, you see that the impurities will go down and the rice will be on top. For instance, you can have substances. Inside that substances, you have some of them magnetic and some non-magnetic. It means that you can separate the substances into magnetic and non-magnetic substance. And what you use is to use a magnet to remove the magnetic substances. So this gives us an idea of how you use the properties of a substance to remove impurities in it. For types of separation technique, we have first among them decanting. We have 2 filtration. We have 3 evaporation to dryness. We have 4 centrifugation. We have 5 simple. We have C is fractional distillation. There are so many other methods, but these are the ones we may mention today. Therefore, when we come to the second lesson, we can mention some other ones. But let's look at decanting. Please, you may write as I teach. You take your notes. Decanting. Decanting is a process which is involved in separation when you have a mixture of solid that are settlable in a liquid. When you have solid which is not soluble in a liquid and it can settle down, you use decantation. For instance, if I add garri into maybe a cup of water, some small garri into a cup of water, you will discover that the garri will go down, especially if you don't allow the garri to soak immediately. The garri will go down. You can now remove the water from the garri. That is decanting. Another example of decanting is that when you have maybe small quantity of sand, you pour it in a beaker and pour some water into the beaker, you discover that the sand will settle at the bottom while the water will be on top. If you want to separate the sand from the water, what you do is you decant. You remove the clear water solution and then recover the sand. That's about decanting. But we need to know our add application. Where do you apply decanting? You discover from what I've just told you, you discover that you can apply decanting when you are cooking. For instance, when you are cooking, maybe you want to cook rice, and you discover that you are using water to wash your rice, you decant the water and then recover the rice to cook. Then another application of decanting is to remove wear from curd. Remove wear from curd when making cheese. Remove wear. Wear is W-E-Y. Curd is C-U-D. When making cheese is C-H-E-E-S-E. To remove wear when making curd. These are the two applications of decanting, but that is not all. You can, on your own, check all what you do when you are cooking or doing any other thing where you apply decanting. Then the second one is filtration. Remember that we've done decanting, and I said in decanting, it's usually when you have insoluble solid that is settlable. Insoluble solid that is soluble in water and or solvent and settlable. Then this filtration, for filtration, it is the same insoluble solid that may not be settlable in a liquid. When you have insoluble solid that may not be settlable in a liquid. Take for instance, you have your beaker and you mix in the beaker some powdered milk. You know that when you add the powdered milk, when you turn it well, you have a kind of suspension. You have a white suspension. You can see that that solid milk does not dissolve totally. If you put a filter paper, you can remove the milk, it will be on top of the filter paper, while the clear water will go down. Let's take another example. If you have maybe a beaker, and you add some chalk powder inside the water. When you add some chalk powder inside the water, you stir it. After stirring it, you see that you have a whitish suspension. That whitish suspension, you can use your filter paper, fold it, then pour the white suspension. You will discover that this is your beaker, either your beaker or measuring cylinder. This is your funnel. This is your filter paper. When you add the white suspension, you have it here. The clear water will be down here, while you have the solid chalk powder on the filter paper. For there are two things. You call this one filtrate, and you call this one solid residue. Sometimes they will ask you this question, therefore let me define the two things. Residue. Right. Residue is the solid that is left on a filter paper after filtration. I said that residue is a solid left on filter paper after filtration. So let's define filtrate. Filtrate is the clear liquid that passes through the filter paper after filtration. Let me go again. Filtrate is the clear liquid that passes through the filter paper after filtration. Let's look at application of filtration. Application of filtration. Where do I apply filtration? Application of filtration. One of the areas we apply filtration is in water treatment. One of the areas we apply filtration is in water treatment. If you go to a water treatment plant, they have sand filters. Therefore, the sand tries to trap the insoluble solid from the water, and the clear water is drained down. Well, one of the application is in purification of water. Then another application of filtration is in purification of air. When you want to purify air, you pass the air from the atmosphere into a filter column. The filter column will trap the dust, and then the clear air and other component of air. You know that air usually contains CO2, oxygen, inner gas, dust, we talked about inner gas, CO2, oxygen, then nitrogen. Therefore, what will be trapped during the filtration will be removed during the filtration will be dust alone. All the other components of air will go through. Therefore, you apply filtration in purification of air prior to its liquefaction. Number 3, you apply filtration also in removing particles from oil. For people who use cars, you know that you have oil filters. Those oil filters trap solids that are in the oil that are not very useful. They will trap it and make sure that the oil that you are passing to the engine have no solid particles in it. For these are the application of filtration. Well, we'll go to the next one, the third one. The third one is centrifugation. Remember some of the principles that guide this separation technique. The first one we talked about decantation. We said that they are mixtures of solid and liquid in which the solid is very settlable. Then we talked about filtration. We said that it's a mixture of solid and liquid in which the solid is not settlable but remain as suspension. Then the third one now is centrifugation. In these ones, you have mixture of solid and liquid in which the solid is unsettlable and is in very small amount, in minute amount. Therefore, in this case now, you have a kind of apparatus. In that apparatus, it spins, it rotates, you on the electricity will be rotating the mixture, and as it's rotating the mixture, the particles that are unsettlable are forced to settle down. Therefore, you have a kind of tube. There are several tubes like this. Therefore, you have the solution. As the thing is spinning around, it's forcing the particles to settle down so that you have something like this. The particles will be here, then the clear solution will be up here. When you have forced the particles to settle down, you can now decant the clear liquid and recover the solid that are at the bottom. You call this one centrifugation. Let's look at where you apply centrifugation. Let's look at where you apply centrifugation. Although, let me repeat myself in case you didn't get it well. I said that centrifugation is a technique used in separating suspended insoluble solid particles in a liquid, and most of the time these suspended particles are in small amount. Therefore, the centrifuge machine will be rotating and it will force this unsettlable solid to settle down. And when you have finished settling it down, you can now decant the clear liquid and then recover the solid which is at the bottom. Therefore, let us look at where you apply this. The application is usually, one, is used in dairy dairy industry. Dairy industry is D-A-I-R-I-E-S. Dairy industry is like in a milk industry. It's used in dairy industry to separate milk from cream and to make skim milk. It's used in dairy industry to separate milk from cream and to make skim milk. Then another important thing is in the hospital. In the hospital, centrifuge is used in separating blood cell into plasma. Therefore, the blood in our body is a liquid, and inside liquid, that liquid, solid are dissolved in it. And the solid are in suspension, it cannot settle down, and it's in very small amount. Therefore, if you put the blood in a centrifuge, the centrifuge will force the solid, the platelets, to settle down, and you can separate the blood into blood cell and plasma. Then we have the next one, evaporation to dryness. Evaporation to dryness. And maybe number 4. Evaporation to dryness. Evaporation to dryness is applied when you have a mixture of solid and liquid in which the solid dissolves in the liquid. Remember that the other ones we've just mentioned, 3 of them, is when the solid is not soluble in the liquid. But that of evaporation to dryness is when the solid is soluble in the liquid. For instance, if you have a measure of maybe a cup of water, and in that cup of water you add 2 cubes of sugar. Alright, let me not use sugar because sugar is affected by heat. Let me use common salt, sodium chloride. And in that sodium chloride, maybe you add 20 grams of sodium chloride in maybe 100 cm cube of water. You know that this 100 cm cube of water can dissolve 20 grams of sodium chloride. If you now stir the solution, you discover that the whole 20 grams will dissolve in that water. Then you ask yourself, how can I separate this common salt solution into common salt and water? Remember that the principle here is that the solid must be soluble in the liquid. And how you can do that is if the solute now is referring to the solid particle that you dissolve in water. If the solute is not affected by heat, you can use evaporation to dryness. But if the solute is affected by heat, what you will use will be crystallization. But what we are discussing now is evaporation to dryness. Let's take, for instance, you do this maybe in the lab or even in your house. You can recover the 20 grams of sodium chloride. And what you do is that you will put, this will be your gauze, this is your tripod stand, this is your heat. And when you add this heat, you discover that at 100 degrees centigrade, the water will evaporate. Therefore, as you are heating it, the water is leaving the solution. At the end of it, the whole water will go out, and the 20 grams of sodium chloride will remain on the bottom of the beaker. Therefore, you have recovered your sodium chloride. But the water that you use in mixing it, you have let it out as water vapor. One of the disadvantages of using evaporation to dryness is that you cannot recover your solvent because you let it out in the atmosphere. But the advantage of this method is that you recover all your solutes, because that 20 grams you dissolve in your beaker, at the end of the evaporation, you still recover your 20 grams. But if you use crystallization, at the end of it, you may get maybe 16 grams. There are two methods of evaporation to dryness. This one we have just done is direct heating. You can do indirect heating. Therefore, this one is direct heating. For you can use indirect heating. In that indirect heating, you have your gauze. You have your triple stand. You have your heat Bunsen burner. You have your beaker. In that beaker, you will have water. On top of it, you put your evaporating dish containing the solution. And you know that the solution is your sodium chloride solution. Therefore, when you are heating, you discover that the heat will be heating the water. And the water will be heating the solution. As you are heating the water, the hot water will be heating the solution. Therefore, in this solution, the water vapor will be expelled. At the end of it all, what you have here will be your sodium chloride. Therefore, you discover that you have done the same thing. But the advantage of this indirect heating is that the solution will not be splashing. It will be giving you gradual evaporation. But here, when you are heating directly, the solution may be splashing. And as it's splashing, some of the sodium chloride, the solute, will go out. For you have two types of evaporation to dryness: direct heating and indirect heating. For let's now look at applications of evaporation to dryness. How do we apply them? Application of evaporation to dryness. One of the applications of evaporation to dryness is in production of salt from sea salt. Like people who come from Ebonyi State, Ubru. In Ubru, you have Ubru salt there. They have a lake that contains salt solution. Therefore, when they go there to fetch the salt water, they can heat it, use their firewood and so on, heat it until all the water evaporates, and then they recover the salt. Or sometimes they will be putting it in the sun for several days. As they are doing it, the water is evaporating. Later on, they can now recover the salt. Evaporation to dryness also can be used in the production of dry milk, starch, and sugar. In this particular one, especially in sugar, what you do partial evaporation to dryness and then crystallization. Because if you do direct evaporation to dryness, the sugar will be converted to carbon, water vapor. Therefore, what you do here is that you do partial evaporation to dryness and then crystallization. These are the applications of evaporation to dryness. We'll go to the fifth one. The fifth one is simple distillation. The fifth one is simple distillation. Simple distillation. Simple distillation. We are going to end with this simple distillation because we will now do some evaluation to see whether what we have done, whether we have following. We'll do simple distillation. Simple distillation is a type of separation technique involving miscible liquids. Or sometimes it can equally involve solid dissolved in a liquid, but the solid must be soluble in the liquid. The liquid in this situation is called the solvent, while the solid is the solute. Therefore, when you have such substances that dissolve in a liquid, you can recover the solvent by distillation. You can recover the solvent by distillation. And distillation is applied, simple distillation is applied when the mixtures have different boiling points. And most of the time, the difference in boiling point must be more than 20 degrees centigrade. Must be more than 20 degrees centigrade. But when it is more than 20 degrees centigrade, what happens? Let's take, for instance, you have a mixture of water and maybe ethanol. In this case, we are referring to a liquid that is miscible in water. Water have boiling point of 100 degrees centigrade. Ethanol have boiling point of 78 degrees centigrade. You can see that the difference in the boiling point is 100 minus 78. That will give you 22 degrees centigrade. Because the difference in boiling point is more than 20, you can apply simple distillation. And what happens is that when you heat the mixture at 78 degrees centigrade, the ethanol will change to vapor. When it changes to vapor, it will leave the container as a vapor, while the water will still remain as a liquid. Maybe let me put the diagram, and that will help in the explanation. You have your thermometer, which you insert in the distillation flask. You have your distillation flask. This is where you have your mixture. This is mixture of ethanol and water. Then you heat as you heat the mixture, the ethanol, which has a boiling point of 78 degrees centigrade, the ethanol liquid will change to vapor, while this water will still remain here as a liquid. Therefore, the vapor will come out from here. Here, you put in your cold water. Here, the hot water goes out. Therefore, that vapor, when it comes here, this thing you call it condenser. When that hot vapor comes in here, this water cools it down. When it cools it down, it will liquefy and fall here as distillate. It falls here as distillate. Then the hot water, because this hot vapor will heat up the water, and the hot water will go out from here. While here is your distillate. Maybe there is need for us to define distillate. Right. Distillate is the condensed vapor. Distillate is the condensed vapor from a distillation process. Distillate is the condensed vapor from a distillation process. Let me leave, the way will come next. I'll start from precaution. Let me do some evaluation to find out whether what we have learned, whether we are following. Adako. From what we have learned, what is a mixture? What is a mixture? Yes, you are correct. A mixture is a substance that contains two or more substances. A mixture is a substance that contains two or more substances. All right, that's okay. Then Okereke, can you mention some of the techniques involved in separation technique? Mention about 3. Yes. You said filtration. Yes, that's one of them. You said evaporation. Yes, that's one of them. Then centrifugation. Correct. Then Okorie. Can you tell us the principle used in decanting? Can you tell us the principle applied in decanting? No, it's not different in boiling point. When you are doing decanting, the principle that is applied there is that the mixture must be solid and liquid, and the solid must be set level, and the solid must not be dissolved in the solvent. All right, Matthew, can you mention the principle involved in separation technique using simple distillation? Yes, you said different in boiling point, but that is not truly correct. There is still another principle involved. Yes, Yes. The difference in the boiling point must be more than 20 degrees centigrade. That's correct. All right, let us look at the assignment for you. At least we have reviewed what we have just said. Let's look at our evaluation or the assignments. Right fast. Explain briefly the following separation technique. A. Decantation. Remember that I said briefly. B. Filtration. C. Evaporation. Remember that evaporation is same thing as evaporation to dryness. D. Centrifugation. E. Simple distillation. All right, that's where we. Then 2. Explain one factor used. Explain one factor used in determining the various separation technique. If you had paid attention to our evaluation, this question becomes a bonus. Because we mentioned technique mentioned above. We mentioned up to 3 of them. Then the third one is give 2 tests. I'm not writing this, but or I leave the third one because we've not touched that. For the 2 assignment is number 1, explain briefly the following separation technique: decantation, filtration, evaporation, centrifugation, simple distillation. Then number 2, explain one factor used in determining the various separation technique mentioned above. That is your assignment. I wish you safe stay, praying and believing God that God will deliver us from this pandemic. I remain Mr. Odemenam Chidube, your chemistry teacher. Thank you and stay safe.